Okay, we're reviewing for our chapter test, which is tomorrow. Okay, make a conjecture. A conjecture, again, is what do you see as a pattern and what would happen next? So what's the conjecture about this figure that would be next? It will have what's happening to the sum number of sides. They're going down by 1. Okay, so this one has 1, 2, 3, 4, 5, 6, 7. This one has 6, and the next one would have 5. So just do your best to draw a regular pentagon. Doesn't have to be perfect. I could have used my tools up here and made a perfect one, but okay, that would be the next term. That's all you needed to put down. For number 2, it says identify the conclusion of the statement. I wanted to bring up that on the last quiz, make sure you understand that the hypothesis is the part after the if. It doesn't include it. The conclusion is the part after the then. It doesn't include the word then. So the animal has wings is the conclusion. Okay. Number 3, which best describes the statement? If 2 lines intersect, then their intersection is a point. Well, if 2 lines cross, there's no way they can cross in anything but a point. This is always true. BA. Which best describes the statement? A plane contains at least 3 points. Well, we have a postulate that says if 3 points, then you get 1 plane. So it's always true. It has to contain at least 3 points. I mean, it has infinitely many points, actually. Now we're going to go through the properties. Oh, another suggestion for you is that, I can't see this little, there we go, that you use your summative reference sheet. If you have that, I would find it now, or hopefully you have your green sheet. We made it green. It looks like this, and it's got a lot of stuff on it. It tells you what a conjecture is. And it gives you an example. It tells you about counterexample, etc. Gives you information on conditional statements. Gives you your properties, which we're about to do. I added on that 1, 2, 2, 3, 1, 3 on it. If you want to write that on your green sheet, that's fine. If you haven't got a green sheet, I do have some extra copies that are white in the back if you'd like to, if you need one. They're in that blue bucket back there. Okay, guys, has your reflexive property showing you about segments, etc., and about congruence. Got your segment addition postulate on it, your midpoint, your definition of bisector, another reflexive symmetric transitive for angles. And you do have to do the right one. If it's definition of congruent angles, it has to be about angles. If it's about definition of congruent segments, you have to write segments. All right, so it has a lot of different stuff on it that you get to use for your test. All right, let's go back to the questions. All right, so we name the property that justifies each statement. Yeah, no. What are we doing to get from here to here? Distributive. Okay, you should write, you're distributing, but you should write the distributive property. And you can abbreviate property. All right, 6 says if angle A is congruent to angle B and angle B is congruent to angle C, then, yep, that is the transitive property for angles. You don't set, you can write just transitive property. Okay, and that's that 1, 2, 2, 3, then 1 and 3 are congruent. If x equals x, which one's that? Like if you don't know, look on your sheet. I got a lot of people running to write reflective. It's not reflective, it's reflexive. And there's no excuses for spelling it wrong when you have it right on a reference sheet. If segment XY is congruent to segment TZ, then TZ is congruent to XY. All I did was flip it, which is, guys, all right, symmetric. That's your symmetric property. Okay, now x equals 3, and if you have another statement that says x times y is 12, you can write a new statement that replaces x with 3 and 3y equals 12, and that's making a substitution. Okay, hopefully you'll do great with all those. Most of you did very well with them on the last quiz. Just substitution, it's fine. It's a substitution property, but I don't think we really said property a lot about that one, just making a substitution. I'm not going to knock people off for not writing prop anyway. Okay. All right, this question I think we're using for 2, 10, and 11. It says the measure of angle ABD, you want to find your angle first, is equal to the measure of angle FGH. FGH. Okay, so they're saying that those measures are equal. That angle goes from here to here. FGH is going from here to here. And it says the measure of angle ABD is 137. Well, then it's asking us to find the measure of angle JGH, which is here. All right, well, if ABD is 137, and they said that the FGH is congruent to it, then this one's 137. What do these two angles form on the right-hand side here? 180. So they're supplementary. Okay, they're supplements. They form a linear pair. So since they are a linear pair, that implies the supplements theorem, saying that 180, they add up to 180. So I know what you guys would normally do. You don't really have to write an equation, and it didn't ask you to name the theorem, but it's good to point out what one it is. You're probably just going to take your calculator, and what are we going to type? Okay, yes, I heard that. 180 minus 137. Okay. And that's, what, 43 degrees? Okay, so what the question was, what's the measure of angle JGH? And it's 43. Number 11 has to do with the same picture, but they've changed the numbers here on us. It says if the measure of angle ABC is 48, that would be here. You can still write on it, just ignore the other stuff. And the measure of angle ABC is congruent to the measure of angle DBE. Well, here's DBE. That's also 48 then, if it's equal to ABC. And they want us to find the measure of angle DBC. They want this angle. So what do the three angles add up to? You don't have to write this down, but by the angle addition postulate, or that they form a linear pair, those angles add up to all three of them, 180. Okay, so angle addition postulate, you can add all three angles to get 180. So we're going to go ahead and just figure out angle CBD by subtracting. Okay, and you just chose to add them first. It's just the same as if you type 180 minus 48, which is 180 minus 96. Ryder said that he added those first, so that's a great way to do it. 180 minus 96 is 84. All right, so we want to write down the measure of angle DBC equals 84 degrees. All right. Find the measure of angle FAD if the measure of angle BAC is 62. All right, so we got to look at the diagram. You see that there's a 90-degree angle here. That box means 90, of course. We know that. FAD is angle 1, and it says BAC is 62. All right, so I want to know this. What do I know about line or angle DAB? I don't know why there's no dots on these. It's a straight angle. So these three angles add up to 180 degrees. So let's just figure out the measure of angle FAD by doing 180 minus 90 minus 62. 180 minus 90 is 90. 90 minus 62, we finish it off for us. 28. And that's how we got it. Now you don't have to write this step, but you can just use your calculator and subtract. Now I think we're using this picture again with some new information. We are. The measure of angle 2 is 2x plus 22. That's here. And BAC is 6x. That's here. Well, if there's a right angle right here, I'm going to give a hint in case you don't see it right away. That's a straight angle. So since angle FAE is a straight angle, and there's a 90 right there, what's the angle EAC? It's got to be 90. All right, so which means these are complementary. They make a right angle. So we can add them up. 6x plus 2x plus 22 equals 90 is our equation. And that's by the complements theorem. Two angles make a right angle, then they are complementary. Add 6x and 2x, that's 8x. I want to combine your like terms first. Now I'm ready to solve by algebra. I'm going to subtract 22 from both sides. You already got it. 68. Okay, and then we got to divide by 8, so I can tell that's going to be a decimal. 8, and it's a nice decimal. 8.5. Yep, or 8.5. Uh-oh. It said to check it. You always want to go back to your question. Make sure you answered it. It said to find x, and it didn't say to figure out any other angles, so I'm done. But oftentimes, there's another angle to find, and you want to make sure you check and see if you finished your answer. Especially if it's multiple choice, okay? Because there might be that answer for answer, but if they wanted us to get another angle, then you would have needed to do some calculations. All right, we got definition, property, postulate, or theorem that justifies the following statements. If two angles form a linear pair, then they are supplementary angles. What is the theorem? It's actually not on your green sheet, I don't think. It's called the supplement theorem. You can write SUPPTHM for an abbreviation. It's the supplements theorem. Two angles form a linear pair, then they're supplementary. This one is going from equal in measure to congruent. That's why, remember, you drop or add the wavy symbol. Drop or add the M's. Definition of congruent. Now, careful, guys. You got to write the whole thing. Definition of congruent what? What are these? Angles, not segments, okay? All right, if x is the midpoint of y to z, of the segment yz, then yx plus zx, or yx and zx are equal. It's saying that they're congruent, not adding. So if it's the midpoint, why are they congruent? This is your clue right there. It's just what a midpoint means. What does a midpoint do? It divides the segment into two congruent segments. So you write definition of midpoint. Yes? Oh, if you wrote the angle symbol like that, that's fine. Okay, now M is between D and P. What I meant when I said by write it out is if somebody writes segments here, I may have to take half a point off. If somebody writes, you need to write angles or segments, whichever it is that you're talking about. Okay, M is the midpoint of DP. It doesn't say midpoint. I got distracted. If M is between D and P, then DM plus MP equals DP. There is a postulate. It is on your green paper. It's not that, because we're not adding angles. So skip over that, find something else. Doesn't this look like what we're talking about right now? It's segment addition postulate. You need to know that one. can write segment add or seg add postulate POST. There's an angle addition postulate and a segment addition postulate. You've got to flip the page. Okay, now we've got an algebraic proof. I'm going to describe to you the difference between this one and the one after it. First of all, though, what the first part is the if, and that has been given. So you jot down what's been given. Now, right here, they're showing that they are multiplying both sides by 5. That's multiplication property. All right, now, if you just showed that you multiplied by 5 on both sides, what have you done to get to 3? What did you do to 2 to get to 3? All you did was, what's it called when you do the make it a little easier? I'm trying not to use the word. Simplify, yeah. Now, I want to explain to you, though, that we don't always show the step, and sometimes we go from here to here. But this one, I wanted to show the step because kids have more trouble with the ones that have, like, division in them. All right, now, next they went from here to here, and they're showing what they're doing. Subtraction. They're subtracting 2 from both sides. So that's your subtraction property. And then they combined the like terms or simplified it to get down to the last one. Now, sometimes in proof, we don't put in these steps, 2 and 4. We just do it. And then you don't write simplify in there because you're not showing those steps. And I'll explain that difference between this and 19. So if you're looking at 19, they have cut some of the steps out. They didn't show them all, right? So what they did first was wrote down the given. Okay. And then the next step, they did something to line 1 to get to line 2. And we have to realize what they did because they didn't show it. Distributive, yep. So that's your distributive property. Okay, now what happened to get, I don't like, we are not using substitution. They added like terms. They did 5x minus 6x and got negative 1x. So 24 minus 1x equals 6 plus 8x by addition of like terms. Next. What did they do to go from 3 to 4? Well, this is missing, right? But what do you do to get that out of there? You add to both sides, you add 1x. So you're actually doing the addition property of equality. Okay, then somehow they got rid of, they did 2 things here. Now, I wouldn't really do this to you on the test and expect you to come up with 2 answers, but I bet you guys can do it. First, I know they got rid of this, right? Okay, but they also did something else. They flipped it. So they did subtraction property. And what's it called when you flip it? And then they did symmetric property also. And then lastly, the x is 2 by doing division. Okay, division property. Okay, so again, I want to show you what's the difference between this one and the last one. The last proof, there was showing some of the work in between. That's why we had simplify when we went from here to here, and we had multiplication there. While as in this proof, we don't have any simplify except because this wasn't even simplify line 3, it was addition of like terms. Okay, so they didn't show the steps in between, so it goes a little bit differently. All right, now I need you to add A, B, and C to the figure, please. Okay, I think everybody's got that done now. Angle 5 is a right angle has been given. That's it. And the box is on the picture. The measure of angle 5 is 90 because that's the definition of a right angle. If you take angle 1 plus angle 3, you would get angle ABC, and that's by something postulate. They're angles, so it's angle. You are adding them. Addition, postulate. Now, if you took angle 5 and angle ABC, by the supplements theorem, since this is a straight line, you get angle 5 plus angle ABC is 180. The next step, I got two reasons I can write the next step. I had said that angle 1 plus angle 3 is equal to the measure of angle ABC. So if I took this and put it in here, I could get that line. So if I did it that way, this would be a substitution. That's sort of how I felt the proof led us. You have to go with how someone else has led you through the proof sometimes. Now, there's another reason, though, the measure of angle 1 plus the measure of angle 3 plus the measure of angle 5 is 180. Aren't those just added up angles again? That gives you a whole straight angle. So you could have said angle addition postulate as well here. I would have taken either one. Or angle addition postulate. Now, this one is taking line 2, you see it? And putting in 90 for angle 5. That's definitely a substitution. How do we go from line 6 to line 7? How'd they get rid of the 90? Yep, they subtracted 90 from both sides. So that's your subtraction property of equality. And then lastly, if angle 1 and 3 add up to 90, then angles 1 and 3 are complementary. That's the definition of complementary angles. You can write comp angles with a symbol. All right, so we just proved that angle 1 and 3 are complementary. Okay, some of us made mistakes with this on the last quiz. Writing an if-then form. Do not try to mess around with the order of things. It says the intersection of two planes is a line. So if two planes do what? Okay, if two planes, if you want to abbreviate a little bit, you may, but if I could write the number 2 instead of the word, but I'm going to go ahead and just write it out. If two planes intersect, then their intersection, not really much abbreviating to do anyway, is a line. It is now an if-then form. All right, we're going to write the converse of the conditional statement. Remember, a conditional statement is if P, then Q. The converse, and it is on your fact sheet or your reference sheet, the converse switches the hypothesis and conclusion. So it's if Q, then P. So we're also going to determine the truth value of the statement that we make. And if it's false, we're going to find a counterexample. All right, so this is P, this is Q. If an animal is a Dalmatian, then it is spotted. We want to do if Q, so if it is spotted, and you can write it this literally. If it is spotted, then an animal is a Dalmatian. Which is a type of dog. Well, Dalmatians are spotted after they mature from being a puppy. They grow their spots or get their spots. But is it true that if it's spotted, an animal isn't a Dalmatian? There are other animals. Okay, so you don't want to write down false. There are other animals that are spotted. Although that's a correct statement, you got to give a counterexample. So you got to give me an animal that's spotted that's not a Dalmatian. All right, you have to make the if part true, a spotted animal, but it's not supposed to be a Dalmatian. And by the way, if you had written if an animal is spotted, then it's a Dalmatian, that's correct as well for the statement here, okay? That's all right if you worded it that way. It means the same thing. All right, it's false. So someone give me an example of an animal that's spotted. Now, a what? Giraffe? Sure. Any others? We didn't bring up giraffe first hour. Cheetah? Oh. It's a bull terrier. The target dog is a bull terrier, yeah. Cheetah. Okay, there's more, guys. Somebody said zebra first hour, and we kind of just chuckled a little bit. What are zebras are striped. Anyway, it was funny though. Okay. We did say you could say leopard. I mean, there's a bunch of them, right? All right, enough. You've got some counterexamples. I don't know if I spelled leopard right, so it looks Leo. I think it's right. Oh well. Moving on. Write the contrapositive. Okay, so remember, your conditional statement starts off if P, then Q. The contrapositive does two things. It negates the hypothesis and conclusion and switches them. It's not Q, then not P. All right, so we want to do not Q, then not P. Here is the PQ. It is if two angles are vertical. This is your P, this is your Q. We're going to do if they are, or we could say if two angles are not congruent, but I think I'll just start if they are not congruent. I'm going to go literal. You negate that, say they are not congruent. If they are not congruent, then two angles are not vertical, right? And most of you did quite well with this on the last quiz. Yes. Okay, so if it said if two angles are, say it started off, the conditional statement says, if two angles are not vertical, then they're not congruent. And you had to write the contrapositive, is that what you're asking me? Oh. Okay, if two angles are vertical, then they are not congruent. Okay, so that would be a false statement, but yeah, you could have a statement like that, and the contrapositive would be, if they are congruent, then two angles are not vertical. So if you have a negative in there and you have to negate it, you have to do it to the opposite meaning. Like if it's cloudy outside, then it's then it's not raining. Okay, the negation of that would be if it's not cloudy outside, then it is raining. Okay, so you just change the meaning. All right, write the inverse of this conditional statement. Well, this one's not written in if-then form, so let's write it in if-then form first. So first, let's say all whole numbers are integers. So if a number is a whole number, just go with it in the order it's saying this. If a number is a whole number, let's use the number symbol. We'll shorten that up a little bit. Then it is an integer. Okay, now that's my if P then Q. We want to write the inverse. The inverse negates the hypothesis and the conclusion. It's not P then not Q. So we're going to write if a number is not a whole number. And let's abbreviate number. If a number is not, and I'm just doing that for writing's sake, is not a whole number or time's sake, then it is not an integer. Okay, so if you're not given it in the if-then form, you need to write it in if-then form and then do the question. So this is our answer. All right, 25. Make a conjecture about the next item in the sequence. I don't want to have you writing, I don't know. I guess this one's pretty straightforward. I know you guys can get the next number, but how we're describing it has been an issue for some. What's going on? We're adding 15 each time. Okay, so the next term is 60 plus 15, which is 75. What I want you to write the rule in words is add 15 to get the next term. Well, this is best. Now, actually, if you wanted to be real nitpicky to describe the rule, it would say start with 15 and add 15 to get each next term. Oops. Whatever. Add 15 to each term to get the next term. I don't know what the heck All right. If you write add to 15, I'm probably going to be fine. But I just want you to have it nice and clear for your studying purposes. No. That's basically what it is, right? You're adding 15. 80, negative 40, positive 20, negative 10. What's the next one? Negative or positive? Okay, now in case somebody wasn't seeing it, that's why I said that. Now, the rule in terms, you need to say divide by -2. Divide each term by I'm going to write it out. Divide each term by -2 to get the next term. And actually, if you wanted to really tell somebody how to generate this list, you'd say start with 80 and divide by -2 to get each next term. All right, good enough. When you look at 27, you look at the picture and you have to say to yourself, what are these angles? They are vertical. And by the vertical angles theorem, vertical angles are congruent to each other. So we're going to set these equal. 7x plus 10 is equal to 5x plus 24. Yes, Shondell? Can you wait a second? Thank you. Okay, two sides to your equation. Subtract 5x from both sides. All right, you guys finish that one up. I'm going to pause for a second. Can you get me back to the review? All right, we paused for a minute. All right, there we go. You guys subtracted 10, I hope, and divided by 2 and got 7 for x. Okay, and then you're supposed to find angle 4, so you would have done 5 times 7 plus 24, which is 35 plus 24, and you got 59 degrees. Any questions on that problem? All right, 28. Use the figure and state the postulate that can be used to show that each statement is true. First, I'm going to highlight my picture a little bit because it's hard to see for some people in 2 dimensions, and this is a 3-dimensional diagram. You don't have to shade it if you've got it. Okay, so one of our postulates, and it's on your sheet, your summative reference sheet. This look like something. Okay, it's asking us points R, O, and T are in plane RNP. Plane RNP. Those are three non-collinear points. So the postulate should look like this. Three non-collinear points, then a plane. That's what it's saying. So find that one on your green sheet, guys, girls, everybody. You got to know how to figure it out. It says if three non-collinear points, then you get one plane. I can take the number or I can take this statement. Which one is it? If you guys, can somebody find that and please tell me what postulate number it is? If you're going to use that sheet and you want to write that down, it's 2 point. All right. Again, if you just write if three non-collinear points, then you get one plane, that's fine. All right. SO is contained in plane UNP. Line SO. All right. Well, if 2 points, those 2 points are in plane P. If 2 points in plane, then whole line's in the plane. Says something like that. Maybe not exactly those words, but if you wrote that for me, if 2 points are in a plane, then the whole line containing those points is in the plane is what it says. I forgot which theorem it is, but you guys have it. 2 point something, again. I just don't remember what the number is. Do you know? Well, I'll take the postulate number or just the statement. I'm leaving it at that. All right, angle 4 is 42. Find angle 1, and then tell how you know this is true. What's the measure of angle 1? This is the easiest question on this whole test. Okay, measure of angle 1 is 42. Why? There we go. Thank you, Malik. Vertical angles. What's it, Malik? Vertical angles theorem. That's funny. Wasn't Malik. Sorry. Who said it? Diego? Gosh, you're way back there. I couldn't even see you. Sorry, Diego. That was Diego. All right. Anyway, doesn't matter. Vertical angles are congruent. Thank you. More than one of you knew that. All right. Given the information below. Okay, look at the picture. We see a box, which means this is a right angle. All right, so given the information, explain what theorem or theorems you would use to find the measure of angle 13. Then show your work and find the measure of angle 13. All right, we're going to use the complements theorem because we're going to say if two angles form a right angle, then they are complementary, which is your complements theorem. So we're going to add up these angles, x plus 2 plus 5x plus 10, and we're going to say they equal 90. We're going to solve by simplifying first on the left side. Then we're going to use the subtraction property of equality and take away 12 from both sides. We got 6 times x is 78. And then we're going to divide both sides by 6 by the division property of equality. X is 13. And then we're going to use substitution. Okay, and that's not a theorem, guys, so we only need the complements theorem to set it up. It's a property. We put in 13 and we get plus 2, we get 15 for angle 13. Oops, that was 13 plus 2. Well, it's definitely not to scale. All right, 32. If A, B, and C are... Ooh, this is a good one. There will be one like this, and you have to pay attention to the numbers here, guys. If A, B, and C are collinear, and AB is 3 and BC is 9 and AC is 6, explain how you can determine which point is between the other two. Look at the numbers. Let's make a statement. Which ones add up to the other one? AB plus AC would equal BC, okay, because that one's 3 plus 6 equals 9. All right, you see how I'm figuring that out? All right, now look at these letters. What's the one in common to these two segments? So that would mean A has to be in between, because that's the only way we can make this picture work out. All right, so A has to be between B and C, because segment, well, that's because AB plus AC equals BC, and that is your segment addition postulate. Okay, now have we hit the last? Yes. All right, this last page is review of some old stuff. Might be good to work on it, but it's not as germane to the test as the previous questions. So I'm going to go ahead and probably record this later and finish it off maybe and add it on, but it's the other parts that's the most important for your test tomorrow. Timer timeout. If I can get it to turn off. My little thing's not popping up here. Why? I need to get this. Edit this thing if it's not. Recorders, click here.